guess I'll get started. So how did everybody do with the assignment last week? Everybody felt good? Working with it? Good. Comfortable now with Slack and the Canvas, and hopefully all the confusion has been sorted out. So today we're going to talk about, we're going to get into, I don't know, some people will find it boring topic. This is just how the World Wide Web works, how networking works. We talk about the client-server model, how your web browser talks to a web server and processes the response that you get. How many people here have dealt with networking at all? Any like network programming? A little bit? What did you do? Oh, okay. So you know about TCP, IP, UDP, the OSI stack. Yeah. That's all right. It's a complicated subject. We're just going to dive into a little bit of it today. It's not going to be just pretty much like an overview of what you would probably get if you were to take a general networking class, and it's even, I think, might be even a little more abridged than that. But okay, I guess we'll get started here. So this week there's going to be a quiz on Canvas. I believe it gets released tonight at midnight. It's going to go over the topics that we had discussed the last couple weeks, the design process, wireframes, compositions, and I believe we'll be talking about week 2, which was native applications versus web applications, and whatnot. There's no time limit on the quiz. I think originally it was like a 20-minute time limit. It's open-ended, so you just, it's like a fill-in type of thing. So we just take that during the week, and then you also have participation, and this week's assignment should be based off of tonight's lecture here. Any questions? Any questions from last week? Cool. Yep. It's just, it's the, I have the PowerPoint slides, the overview, and it's pretty much open book. I mean, you can use, it's online, so I mean, there's no way I'm gonna, be able to hawk over what you're doing. But yeah, it's you can use the internet as a resource. You can also use the readings that I have in there. Trying to remember, I think I'll set up a page tomorrow morning with that just lists the readings that I had for weeks 2, 3. I think week 1, I think I had some readings there. That way it's in one spot too, so that you don't have to go back looking through like the announcements or the Slack messages. So actually, let me make a note of that to so I'll do that first thing tomorrow morning. Okay. Any other questions? No? There you go. All right. So we'll get started with the material. So today I'm going to go over client-server architecture, and then the second part of the class I'm going to show you Chrome developer tools. How many people use Google Chrome, I guess, first question. All right, most of the class. How many people have ever used the developer tools or even knew that there was developer tools in Google Chrome? 1, 2, 3. Okay, good. If you don't mind me asking, did you use the tools at all, or did you just know that it's there? Okay. We're gonna just dive into the different panes. It's a good toolkit to use for debugging client-side issues that you may have when you're developing your web applications. So we're going to do that in the second part of class. So let's get started with client-server architecture. So client-server architecture is a distributed model. It's pretty much a way. There's a whole theory on this type of on distributed systems. But the way to think about it is, if you have a program that you want to have spread out through a network, or have compartmentalize it between different sections, you'd be creating something that's a distributed application. So, for example, let's say you're creating an e-commerce website, and it's going to be, say it's Amazon.com, it's going to be hosted and available to millions of people, but you want it to be built. Usually you create these things to build into scale. So sometimes you'll have, instead of everything hosted on one system, you'll have it spread out across multiple systems so that you can expand or contract as you need to. For example, like the products that you have in your catalog, that might be a separate, what's called a web service that you'll have that you'll use to not only serve up the main homepage of the Amazon website, but you'll also use it to do things like set up the affiliate links, to have people submit reviews on products, email notifications, etc. So this would be a distributed application. So it consists of, you have a server or servers that host the program and distributes the resources to clients that request them. So normally the way this works is through a messaging type of system. When you do any sort of network programming, generally you're sending messages back and forth between the connection you're making from from your computer to another computer that's on the network. So the server hosts the program and resources that the client is going to request. And the client, of course, requests programs, resources from servers, and then processes, an important part, processes the response that's received. Now, what would be the difference between a client-server architecture versus something that's like a peer-to-peer architecture? Does anyone know? Anyone? Okay, go ahead. So you have one that's centralized, right? Server is the central, and then the peer-to-peer is more decentralized, right? Type of environment. So, for example, you have BitTorrent, right? How many people have heard of BitTorrent? How many people use BitTorrent still to download the illegal movies, right? So the way BitTorrent works is, BitTorrent does have some aspects of it, or it's almost like a hybrid. You'll have servers hosting the, what are called like the lists of, you have seeders and leechers. So usually BitTorrent, you'll have at least a main server, the centralized spot to go to connect to at least know who's out there that has the file or parts of the file that you're looking for. So then what happens is you get this list, and then it's up to you, once you get this list from the main hub, you then go out using the list to find other people on the network and request files or parts of the file to download. Whereas client server, everything is hosted on the server, and the clients are connecting to the one centralized machine to get its, to run the program or download resources. This doesn't necessarily have to be just one machine. It could be a bunch of machines acting in unison, but you do end up most of the time connecting at first to one endpoint, and then that endpoint is sending you the files to consume. Any questions on that? No. Okay. So now we get into, how many people have heard of HTTP? Almost everyone, right? Most of the class. HTTP is what's known as the protocol in networking. A protocol is it's like a defined language of it's an agreed upon way of how you're going to talk to each other. So you have, for example, you have HTTP for the World Wide Web. I don't know if you ever heard of FTP. FTP is file transfer protocol that's used mainly for downloading files from the server. You also have SSH, which is secure shell. The list goes on and on. But a protocol is pretty much how the two computers are going to talk to each other. So in this case, for the web, it's HTTP is the protocol. It's the foundation of the World Wide Web, and there's a few things you need to know about it. It's normally used over TCP connections. So TCP is going into now like the OSI stack. You have two types of network connections. You have TCP or UDP. TCP essentially you make a connection to a computer, and then that connection, whatever you send to the computer from the application level viewpoint, it's guaranteed to, what, like say you send data to the computer, you have a way of knowing, at least in it's called transmission control protocol, it'll send you a acknowledgement back letting you know that the data was sent successfully to the server. So usually TCP, you don't have to worry about, if my packet, let's say, made it to the destination. It's built into the protocol, the TCP transmission layer, that if it wasn't sent successfully, there'll be what's called a retransmission, and then eventually it'll retry, where it'll try to attempt to send the packet, and to your application, it doesn't, you don't notice if it was sent or not, versus UDP, which is, UDP, you have no guarantee of knowing whether the packet was successfully sent to the server or not. So that's, I don't know, I might have went a little nuts there. You also have what are called ports. So when you establish a network connection, you normally have a port that you connect to, or if you're the server, you have a port that you are listening on for people to make incoming connections. So for the internet, for HTTP, you have where ports 80 and 8080 for unencrypted traffic, and then you have port 443 for encrypted traffic, which is done through it's usually TLS or SSL connections, and that gets into cryptography aspects for it. So once the connection is made to the server on the specified port, usually you start the message sending process. So in HTTP, you have, there's actually a lot more methods, but the most common are head, get, post, put, and delete. And even then, most of the time, you're going to be dealing with get and post types of requests. This is important to know if you ever get into doing any type of server-side programming. So, for example, if you were to create a page that allows you to submit a form, like for an email list, let's say, you would normally do what's called initially when the person gets to the page, he or she is submitting a GET request to get the web page, and then that form on the page, they'll fill out the form, hit usually like a submit button, and when you hit the submit button, the web browser will do what's called a post, which is it will send data to the server for it to then go and read in the message and then do whatever processing it's got to do, whether it be save it to a database, save it to a file, or send it to another section of the website. As we said before, it supports TLS or SSL encryption. And another important thing to know is that HTTP connections are stateless. How many people have heard of cookies, web browser cookies? All right, good. Normally, I guess nowadays, right, you have people are concerned with tracker cookies, correct? Like, for advertising purposes and whatnot. The original use of cookies was really to help preserve state during a connection. So, for example, when you log into a secure website, because every request that you make to the server is not necessarily doesn't actually preserve any type of connection state. You need a mechanism to say, hey, I have a session, a live session going on with you. So to do that, they have a mechanism called the cookie, which is usually you'll log into a page, right? And then what will happen is if you have a successful login, the server will send you a cookie back that your browser stores internally. And then on every request afterwards, we'll send that cookie to the server so that it knows that you are authenticated, you are a specific user, and it gets processed along with your HTTP request. Does that make sense to everybody? Anybody have any questions? No? Okay. Pretty boring stuff, right? I feel like it's important to know. So this is a little diagram here. So you have your client, your server, right? And then, so the first thing that the client is going to do is send the server a HTTP request, which is normally a GET or a POST. Server then goes and then processes that request using some sort of server-side technology, whether it be PHP, Python, Node.js, the .NET framework, whatever is the big thing to use at the time. And so that's usually the server-side code that will run. The code may then go and do database queries. It could do saving things to file, pulling things from file. Does some sort of processing, like I said, whether it be retrieving something from file, doing some sort of database thing, doing a computation. But in the end, it's going to generate HTML, CSS, or JavaScript as output that's going to be sent back to the requesting client. So after it does its processing, it'll send a response back, which then goes to the client, and then the client then goes and will process the resources that were sent to it, so that so it can display it to the user that's connected to the server. So what is happening? So when a link is clicked, browser initiates the TCP connection, and then sends the server an HTTP request. And that normally looks something like this if you're in Chrome Developer Tools. So usually the first thing that you do is you have a GET, you then have the host, and then the host actually this is what's called a DNS name. So the DNS name stands for domain. This isn't going to be on the test or anything, but the DNS is called Domain Name Service, and usually you connect to a DNS server, and then you're given a IP address, which you then use to locate the server to do your communication. And then the last part there is the type of response that you're getting back. So in this case, it's HTML, which is also a form of XML technically. It's a tag-based language. So the server handles the request. As we said before, it does run server-side code, whether it be a database lookup, form submission, or a computation. And then this is some example of server-side code. This is PHP code here. And you can see up at the top there, the $_post is the way in PHP that it accesses the response, the post message to pull the data out of the actual request that was sent. So if we look here, it's processing the post message. If post submit, so if that's in the request, then it's going to go and do this whole thing here, which it looks like it's going through and just sending back a hyperlink and some sort of messages here. So the server responds back to the client after it does its server-side processing. And then the message will include a status code. So the status is got to let it know if if the request was okay, if there was a problem, say the resource it was looking for was not found, or if an error occurred while doing its processing. The content length, which is the size of the message, lets you know how much data is going to be sent over for the response. So the web browser knows, how much data to pull down. And the actual content type, whether it be HTML, JavaScript, images, could be even, say, Flash, SWF. I mean, a lot of people don't use that anymore, but it could be pretty much anything. It could even be a file, like an Excel file, a Word document, any type of file type. Usually lets it know in the content type. Oh, I'm sorry. The status code actually shows up in the response. So the URL is the way it's going to. So for example, if we go to Reddit.com here, right now, Reddit.com. There's actually something I'm kind of leaving out too. When you go to a URL, this Reddit.com here is what's called the base path of the URL. And then what happens too is you can send it in the GET request. You can send it parameters. So in this case here, /r/all. It's actually sending it there's a section in the HTTP protocol saying, go to this resource. I forget the exact name of it now. I'm sorry, but usually these end up as parameters that get sent in the GET request. And yeah, normally, like if you were to look at this through like a network sniffer, let's say, you're really just seeing that, it's going to whatever IP address Reddit.com translates to via the domain name service. The status code is going to show up if you were to look at the HTTP response, which is like, you usually don't see that unless you have say Chrome Developer Tools up. You'll see the actual response in an embedded HTTP message, if that makes sense. Does that help? Okay, yep, no problem. Any other questions before we move on? No. So this is actually here, this is an example here that's showing the response here. So in the response, you'll see the status code up here. It'll actually show you the version of HTTP that you're speaking in. Usually now they have 2.0 out, I believe. I think that's like the next big thing. But yeah, normally it will be version 1.1. You get the status code of OK. That lets you know that everything was, that everything was good. There was no issues with the request or with the response that's coming back. The size, the message, and then the type here. So you also have, so this is also showing the character set, which is UTF here. And then after that, then it's the actual, the content after that. So in this case, since it's HTML, you have HTML that shows up after the header information from the response. So you have different status codes. 200 is usually is okay. 404 means resource not found. 500 is a server error. 500 usually happens when there's a glitch with the server side programming and there was an unhandled error exception. We usually throw a 500 error. Then you also have these other ones, 300s or redirections. Redirection is when you connect to, say, Reddit.com, for example, and then for whatever reason, Reddit.com, the homepage sends you to a different section of the site via server-side processing. So normally that's done through what's called a redirect, which is a 300, which sends a 300 back to the client, and then the client then knows to go to. It happens behind the scenes without you recognizing it normally. That's usually a redirect is when you're sent to another section of the site. So the web browser, so once the response comes back, web browser will take the HTML, the CSS, the JavaScript, and process the content. Because just having that data by itself doesn't necessarily mean anything without the client actually doing something. So for HTML, normally first thing the browser will do is it'll take the HTML and put it into what's called a document object model, or the DOM. Then applies CSS layouts to the elements, and then execute JavaScript code using the built-in JavaScript interpreter. And then that's what you get as a result, for your typical web page. And then also too, once it's displayed, it's not necessarily done, because you can still interact with the page in your browser. Sometimes you'll have what are called CSS animations or JavaScript code that will go and, say, manipulate the page. So, for example, like on the left side here, you may have CSS animations or JavaScript code that when you hover over, will highlight the actual section that your mouse has hovered over in as a display effect. Any questions? No? Okay. So now I'm going to get into Chrome Developer Tools. So if you don't have Chrome, actually most web browsers will have some sort of developer toolkit that looks, they usually all look the same. In this case, for this class, we're going to use Google Chrome. So if you have the Mac and Google Chrome, I believe it's Option Command J to bring up the developer tools, or you can go up to the View Developer and then Developer Tools, and then it will bring up this little pane here on the side. So there's a few sections here. The first section that you can see here, you have the Elements tab. This here is going to show your HTML, the HTML that's being displayed on your web browser. So in this case here, if you have the HTML tag, you then have what's called the header up here. The header has a bunch of elements in here that normally loads in stuff like CSS, JavaScript, that's going to be used for the page. And then you have the body. And then as you can see, as I'm moving my mouse, it's actually highlighting certain sections of the page. If you want to actually go to a specific section, you can click on this little arrow thing here, select an element, and then highlight over it, and it will actually bring you to the spot that you're looking for. So in this case here, if I highlight over that input element here, you can see the tag that it gets associated with. You can also right-click on it and edit the element. So in this case, I wanted to change the placeholder text. Go ahead and change it to click off of it, and you can see on the page here, it changed over to something wild. Now, when I make these changes and I refresh the page, is that still going to show up? No, right? Because why is that? That's right. So the changes I make here are local to myself. I go to refresh the page, right? I'm making a new request, and that request is essentially blowing out whatever changes I made to the page here. So if I go ahead and refresh, you can see it reverts back to the original page there. So another thing that you have the console here. The console shows essentially it's used for the JavaScript interpreter. So you can actually run JavaScript code in here. So for example, if I did var I equals 1, and then I plus 2, get 3, do console.log hello world, and then it shows. Now, when you write JavaScript code, sometimes these things here, like so for example, you can see up here, the studio.sdk, it's actually doing, at some point it did a console log, and sometimes you do that for debugging purposes, because console log, it's not going to show in your the actual HTML display. It's going to usually be something that's hidden away in the output, the standard out of the JavaScript interpreter, which normally isn't displayed in the web browser. You probably remember a lot of people, they took Java, right? You guys remember standard in, standard out, standard error? Did you guys go over that? Same principle here. You actually have access to that in the browser using the JavaScript interpreter. You also will see errors pop up here. So for example, let's say if you had script code, for example, that was running and runs into an error, you'll actually see it pop up in here, and see if we can actually get that. If I do something like, I don't know. What's that? Oh, you do? For which site are you on? Reddit? On Reddit? Why am I not getting it? Oh. Oh, okay. Yep. Yep. So that's in the, so you're getting so it's probably making what's called a XHR request, which is in JavaScript, it's like so you can do things. How many people have heard of like XHR or asynchronous or AJAX requests? You have half the class, right? So an AJAX request is in JavaScript. You'll have it's almost like a little program that runs on the client. And what will happen is as the program's running, sometimes it has to make a request for data. and then what it will do is make a request to a web service and get back which is an HTTP request, but instead of getting back HTML, it gets back some sort of data like JSON data, JavaScript, object notation data, and then it will use that, process it, and then manipulate the HTML DOM to show you the result. So let's see if we can find that. And the way you can see that is if you go to the network tab here. So you can see here I just sorted it by type, and you see these little XHR for these different, if you click on it, you see the actual response. So in this case here, it was responding back with HTML code, which I'm sure at some point they probably put it into an element. And then if you go to, like, say, the headers, you can see the request header, the method it used to post, and then you can also see too the what it posted. If you scroll down to form data, this is what it actually sent over to the URL or the server for it to process and then respond back with. That's XHR. That's just something to look for when you're for the assignment. I believe that's one of the things you have to do is to look at the network tab and at the different elements that you see in the network tab. So if we scroll up, we'll refresh the page. You can see here. So also what happens too is we scroll to the trying to find the first. I have it sorted by. So this is the initial request that was made here. So the initial request, and then if we look at the bottom, there's the script errors down here, which is interesting because all we did was refresh the page, and now we're getting script errors. This is good to know because a lot of the times you'll have what are called race conditions, and sometimes people, when they program these little JavaScript routines, they don't take into account that, when they go to make these XHR requests or they go to do something asynchronously, they always assume that it's going, I'm going to finish, this one process will finish and then the next process will start, or I'll have the data ready to start my next routine, which isn't always the case. That's what's called a race condition, is when you're betting on the fact that, when I go to make this request, it's going to finish before my next line in the code. Because what happens is when you make an XHR request, it's not serial. It's not serialized. It's not a serialized flow. It's actually, you're actually splitting off into branches, that's where you end up getting into trouble when you split off into branches and then don't wait for the branches to join up at the end there. So we have the network tab, sources. So under sources here, you'll see all the, it's actually lists. So we have Reddit.com, and then also it has all these other, looks like mostly ads that are loading here. So this just shows the different resources being loaded at each level. And yeah, you have your errors and your warnings here. If you want to debug it, you can actually click on this, and it will bring you to the line where the error happened at. Now, if you look here, why is this all on one line here? Does that look normal? So what you can do here is you can just say something like pretty print. And what that'll do is it'll put it into a more readable. This is usually what you see right when you guys code is more readable format like this. But why would you have it sent over to the client in that way? What would be the reasons? Less lines? It is true. It is for more efficient processing. Because if you notice too, even look at the variables, right? A lot of the variable names, right? You have bar A, bar B. The way it's put together, that's true. Where it would be more efficient for processing. What about the size of the file? So one of the things that you see here is with any networking type of application, you normally want to send the least amount of data that you possibly can, right? During your transmission, you want to do what's called compress the data, send it over the wire, and then on the other side you want to uncompress it, because what that does is it frees up the network, and you'll receive the data quicker, because it'll be faster to send something compressed that's, say, 1 kilobyte in size versus sending something that's 5 megabytes in size, right, over the wire. Usually the bottleneck when you have these type of applications is the actual network transmission of the resource that you're downloading. Then also we have the application window, and this is showing us the stored data that's in our session for our web session here. You have cookies, which is what we were talking about before, for preserving state. In this case, Reddit just automatically sent us this cookie, and you can see there's just all sorts of nonsense in here. And normally your cookie, usually you get a cookie, and then the cookie has what are called name-value pairs in them. So you may have an application, for example, that has like a login or a session ID or something. So that will be in the name would be, say, the session ID, and then the value, you'd have it be some sort of random, string generated, usually via like a hash function using a random integer, and then have that stored on the server, and every time a request is made, you'll have that ID sent over to you, and the server will get look for that ID and then know, oh, hey, this is, John Boy here, I'm going to send his information over the over the wire. It's a form of authentication. You also have local storage, which is a new, this is an HTML5 type of thing. Local storage allows you to save a lot more data in a persistent manner. When I say persistent, what do I mean by that? When something's persistent. What's that? It's it's something that you can. It's like saving a state. Something that I could start up again, right? Like a persistent connection means or persistent. Like Google Docs. Yep. So Google Docs, you go and you save your document, right? You don't have to go and restart the document over again. You can just go back to it, load it in. It saves its state as persistent. So that's what local storage is. A lot of places now they use local storage for caching. A lot of times you'll even like images and JavaScript, CSS, even HTML. A lot of times will be cached in the web browser to actually save you the round trip of having to go and re-download the file so that it appears to load quicker on your end. Usually you'll get the web browser will send a HTTP request, and then it may send back one of those status codes that says, hey, this resource that you requested, it hasn't changed since the last time you looked at it. Just load up the one that you have saved in your cache. So then the page appears to load a lot quicker for you. I think we covered that. Covered the network, right? Also in the network tab, you also have that cookies tab here. So this is just another way to get to viewing what was. You get to see what was sent. That cookie was sent in the actual request that was made through this tab here. Trying to think if there's any other. You can see now another thing you can do too when you now when I just did that there, what happened? I went up to the browser, changed from HTTP to HTTPS, or I changed from HTTPS to HTTP, and I hit return, and now I'm on HTTP. What happened there? What do you think happened behind the scenes that caused that? Anyway. So that was a redirect. You can actually see it right here. You see that? 307 internal redirect. So normally websites now, when you go to the you connect to it using the HTTP protocol. It's normally going to redirect you now to the secure version of the site because it's a way of protecting users from possible bad things. For example, like let's say you're at a Starbucks or somebody at the Starbucks is doing some sort of, Wi-Fi trickery, posing as the Starbucks Wi-Fi, hotspot, and you connect to it. What happens though, even though you're connecting to that person's hotspot, and you're going to, let's say, instead of Reddit.com, it was to a banking, website, and you go to the insecure version of it, using HTTP, it'll redirect you to HTTPS so that the connection is encrypted and that the person in the middle that's trying to read your traffic can't actually read the traffic unless, it somehow got your private key, which, you have to somehow actually be on the physical, you'd have to get on the physical machine to get the private key used for the communication between the secure server and the client. Any questions on any of this? No? All right. That was pretty much all I wanted to cover today. For next week, for the assignment, I just want you to write up roughly a one-page paper on using Chrome Developer Tools. It could be one page, I guess I should have put 12 font, double-spaced. I'll edit the assignment I'll post it up in the announcement. I'll edit the assignment to say that. Using Chrome Developer Tools, go to one of the top 25 websites and just browse it using the developer section and come up with a report talking about the HTML tag, which is, I didn't really get into this. So the HTML tag, HTML usually has the structure of, you have the HTML, you have the body, the head, and then the body, which is the content of the website. That's something we'll get into next week. We get into HTML and CSS. But yeah, just give a description of that, the sources, what domain servers it was connecting to, number of requests that you got back. I think you can actually get that. I think it'll give you like a tally on the side here. Yeah, like you can see down here, 139 requests, and then how much was transferred, the amount of time it took. You use it for benchmarking. Also on the side here, we'll see what took the longest too. Over here, it was like really took too long in terms of request time. The cookies, application cookies, and then the certificates used in the HTTPS connection, which you can see if you go to the network. Let's see here, if we go to actually, it's probably under security. Yep, yeah, it's under security. So if you go to security, use certificate, that's the actual certificate that was used so I'm not going to get into how certificates work. Is anybody interested in that at all? How a little bit? Yes, I'll post something up on it explains it. It's pretty much public, private key. It's pretty interesting. It's a way of it's cryptography. It's called public private key exchange, and it's pretty interesting how it works. But yeah, so that's how you would find the certificate when doing the assignment here. Any questions? No? Okay. That was about all I had for today. If you want to get started on the assignment, we got about 20 minutes left. I mean, you can either start the assignment now or do it with, at home. Be here for another, 10 minutes. If you have any difficulties with anything here. All right. So that's it.